Welcome back, geometry students. We are on our last video of quadratics. Woohoo! And so what we're going to talk about in this video is really just something called the discriminant, which I was telling you about. And then I'm just going to kind of go over some basic solving, like solving using any method. So we've kind of been very specific on our videos, or on my videos, about going through like solving by square root, solving by, completing the square, solving by. So what I want to do now is just kind of go over a few, like could you tell what the best method is for solving when just looking at an equation? All right, so before we get to that, let's talk about something called the discriminant. And I talked about that in the last video a little bit. So it's actually part of your quadratic formula. Okay, so the discriminant is the formula b squared minus 4ac. So if you remember from the quadratic formula, it's the part that's underneath the radical. It's not the radical itself, but it's the part that's underneath it. And so what this is, it's that value that's under the square root. And why that's important is because that value dictates how many solutions you're going to have. So let's think about this. So you have your quadratic formula, right? Negative b plus or minus the square root of b squared minus 4ac over 2a. So if this whole number, so we're looking at this number right here, if this number is a positive number, okay? The square root of a positive number will always result in two answers, okay? So like the square root of 25 is 5 and negative 5, because you have the plus and minus in front of here, right? The square root of, 10 is the square root of 10 and negative root 10. So there's always going to be two solutions if this number is positive. If this number is negative, however, the square root of a negative number, and we talked a little bit about this in some of my classes, but the square root of a negative number doesn't exist. And so the world of mathematics has created this whole other world called imaginary numbers. And you may have heard about it, and maybe not. But basically what an imaginary number is the square root of a negative. Because in general, we're not allowed to take a square root of a negative, right? The square root of negative 4 doesn't exist because there are two numbers. There's no value, right? That if I multiply by itself, it's going to equal a negative number. So when you have a negative number under here, what this means, when the discriminant is negative, it means that there's going to be no real solutions. So in other words, if solutions relate to x-intercepts, it means there are no x-intercepts. And I'll show you what that means here in a second. And the other scenario would be if I had this discriminant to be 0. And so if I had the square root of 0, that's the only value that doesn't give us two solutions. So like the square root of 0 is just 0. There's no such thing as plus 0 or minus 0. It's just 0. So when this value, this discriminant is 0, we only get one solution in our equation. And so how that's going to look on your graph is going to be a little different. That means it's only going to be one x-intercept. So there are two things the discriminant tells you. It helps us determine the number of solutions and x-intercepts. So again, there's a slight difference between the two. Solutions can be real or imaginary, right? And so when we get into Honors Algebra 2, you'll be talking a lot about imaginary solutions. But x-intercepts have to be real because those are physically the parts where the graph touches the x-axis. The other part, it determines the type or the kind. And so what I mean by that is really what I'm referring to there is what I'm referring to here is like, are they real solutions? Are they imaginary solutions? Is there one solution? So what does that look like is what we're kind of getting at. All right, so let's take a look at our scenarios. So I'm going to have you draw kind of three little grids. So just three little x and y axes. And then I'm going to have us graph just kind of real, nothing real strenuous here, nothing too specific. I'm going to have you do three different graphs. The first graph is going to have two x-intercepts. The second graph is going to have one x-intercept. And the third graph is going to have no x-intercepts. So again, from looking at this equation, we can tell this has two x-intercepts. And the number of x-intercepts are the number of times the graph hits the x-axis. This one, because it touches and bounces off, has one x-intercept. And then this one, because the parabola never touches the x-axis, it has no x-intercepts. So what this means is when we have a graph that looks like this is the number of x-intercepts we're going to have. In addition, how this relates to the discriminant is what I was telling you about before. If the discriminant is positive, okay, so that means b squared minus 4ac is greater than 0. So the discriminant is positive. That means I'm going to have two real solutions. So again, the word real here just means real numbers are every number in the whole wide world that you can possibly think of. The only thing that we have never dealt with any number except for real numbers so far. And so next year when we get an Honors Algebra 2, you'll be talking a lot about imaginary solutions. And so that's why we say that they're real solutions. It's because there's a whole other set of numbers that exists that are technically called imaginary solutions. And so we're trying to differentiate between the two. So what this means is this type of graph, when the discriminant is greater than 0, so think any number greater than 0, you'll have two x-intercepts and two real solutions. When the discriminant is 0, so here's my discriminant, it equals 0. So this is the only one where if I'm going to take plus or minus 0, I'm going to get the same answer. There's no such thing as plus or minus 0. What happens here is I get one real solution. And so again, what we call this is we call this a double zero. This would be one of those examples of where you have like, let's say for example, an equation was in factored form and you had x minus 5 times x minus 5 equals 0. Okay, and I'll just show you a quick example of that. So let's say I factored something and I got my solutions to be x, or I got my factored form equation to be x minus 5 times x minus 5 equals 0. If I solve each of those factors, I'm going to get the same answer twice, right? I'm going to get 5 and 5. What this means, I'm going to get one x-intercept. It's going to hit my graph at 5 and bounce off. That's what that's going to mean. So next year when we talk about this whole unit called polynomials, we talk a little bit about double zeros, triple zeros, and all kinds of things. A double zero just means two of the same zeros at the same spot. And so graphically how you can tell it's a double zero is because it always bounces off the graph anytime there's two zeros at the same spot. So if there's two 5s, it's going to bounce off 5. Well, it's two negative 1s, it's going to bounce off negative 1. All right. Last but not least, when this discriminant, so b squared minus 4ac, is less than 0. So in other words, it's negative. So when this number underneath the radical is negative, we have no x-intercepts and no real solutions. And so what this implies is, again, this is where we're going to have imaginary solutions. So for those of you who want to play around with it, I can kind of show you how to do imaginary solutions a little bit, if you'd like to get a kind of a head start for next year. But again, when this discriminant is less than 0, so when the discriminant is negative, we're going to have no real solutions, and that doesn't mean that we don't have a graph. Okay, it doesn't mean that we don't have an equation. It doesn't mean we don't have a parabola. We still have a parabola. It just doesn't touch the x-axis. And so that's what it means when we have kind of what that discriminant tells us. So how are we going to use this? Well, so sometimes it's helpful to just kind of look at the discriminant to determine, let's say I give you an equation, to determine the number of solutions. So depending on what you have in front of you, like if you had a graphing calculator in front of you, the easiest way to determine whether or not this has, two solutions, one solution, or no solutions would be to graph it, right? And look how many times it touches the x-axis. If you didn't have a graphing calculator in front of you, another option is to find the discriminant. So if I do if I do b squared minus 4ac, that's our discriminant. If I plug in my numbers into this equation, so this is the discriminant, right? So if I plug in my numbers, so b squared would be 6 squared minus 4 times a is negative 1 and c is 3. Let's see what I get when I get this. I get 36. This would be 4 times 3, which is 12. I get 48 as an answer. So my discriminant is 48. To be really honest with you, I don't care what this number is. It could be, this number has really no bearing. The only thing this number tells me is if it's positive, like it is, this means I have two real solutions. And it means I have two x-intercepts. If it were negative, it would mean I'd have none. If it was 0, it would mean I have 1. So again, all we're looking for here is when we look at the discriminant is we're looking to see if it has 0, 1, or none. All right, so on the next one, let's do another example. So I have x squared plus 6x plus 9. Again, I might ask you to find the discriminant and then interpret what the discriminant tells me. So here's my discriminant, that's the equation. Let's plug in our numbers. So 6 squared minus 4 times a is 1, c is 9. So 36 minus 36 gives me 0. So when my discriminant is 0, this means I have one real solution and one x-intercept, or one x-intercept. And then last but not least, I have a scenario in which I would have none. So let me show you one that would look like that. Okay, so here's a quadratic. Let's say I asked you to find the discriminant and then interpret what that means. So you would do 3 squared minus 4 times 1 times 8. You would get 9 minus 32, which is negative 23. My discriminant is negative. What this tells me is that I have no real solutions. In other words, my solutions are negative, or are imaginary. This means I have no x-intercepts. All right. Next thing is let's just kind of look at some examples of just solving various functions, okay? I just wanted to review this because this is the end of this little section here. This is the end of my quadratics, our quadratics unit. I just want you to solve using any method. So I'm going to write down a bunch of equations, and I want to just kind of go through them here in a bit. So go ahead and write these on your paper, and we're going to solve these together. And then I'm actually doing quite a few, so we'll go through these. We'll do 6. Okay. All right, let's start. So first rule is, this is a trinomial, so it's an x squared and x, and then there's some constant terms. Always check for factoring first with it's a trinomial. So my first is to go ahead and set this equal to 0. So I'm going to subtract 16. So you have two options when it's a trinomial. You're either going to be factoring this or you're going to use quadratic formula. Really, those are the two best choices. So I'm going to try to factor this one. So I'm going to do x and x, numbers that multiply to negative 12. So think about numbers that multiply to negative 12. So 1 and 12, 2 and 6, 3 and 4. Can I get any of these numbers to give me negative 4? And I can. If I make this negative and this positive, 2 and 6, I can get a negative 4. So positive 2 and negative 6. So again, those multiply to negative 12, but add to negative 4. So now my solutions then would be x equals negative 2 and x equals 6. You do not need to write these as points, like as intercepts, unless I ask you for an x-intercept. Okay, so that's a trinomial. Again, two options for trinomials, either factor it or quadratic formula. Okay, this equation, notice what format it's in. It is in vertex form. So when this equation's in vertex form, the only option I want you to use is the square root method. And so what that means is you're going to subtract 7, and then you're going to square root both sides. You're going to isolate that x minus 5 that's being squared. So you have x minus 5 equals plus or minus root 3. In most cases, I'm going to have you leave your answer in reduced radical form, unless, of course, we're graphing, then I would have you write it as a decimal. So we're going to add 5 to both sides. So I get a final answer of 5 plus or minus root 3. Again, vertex form equation, I want you to use square root method. Okay, number 3, it's a trinomial. You have two options, quadratic formula, factoring. So let's try factoring. So x and x. Do we have numbers that multiply to positive 7 that add to negative 8? So there's only one set of factors for 7. It's 1 and 7. And if I make them both negative, they would add to negative 8, but multiply to positive 7. So I get x equals 7 and x equals 1 are my solutions. So we're going to do a little bit more in class with how to factor something when the a term is not 1. But for now, when the a term is not 1, unless you know how to factor this, and this one actually isn't factorable, I would kind of go, if you're solving, I would go ahead and use quadratic formula. So negative b, which is 1, plus or minus the square root of b squared, which is 1, minus 4 times a times c, all over 2 times a. So I got my calculator. I get negative 1 plus or minus, so I'm going to do 1 minus 4 times 3 times negative 5. Oops. 1 minus 4 times 3 times negative 5, and I get root 61 over 6. So again, what does this tell me? Well, my discriminant is 60, means my discriminant is positive, which tells me I'm going to have 2 solutions. 61 is a prime number, so then this would be my final answer, because I can't reduce root 61. Okay, notice this one. It's a binomial. There are only 2 terms. One's an x squared, one's a number. Whenever you have a binomial and there's only an x squared and a number, you want to use the square root method, which means, or you could factor, okay? So it's either square root method or factor. So one option you could do here is you could divide both sides by 18 and then square root both sides. I'm going to show you another way. So another option is to go ahead and factor your equation. So I'm going to factor out a 2. So I get 9x squared minus 4. And then if you notice, this is a difference of 2 squares. So my solutions become 2/3 and negative 2/3. And then the last one, I want you to kind of do the same thing. Notice that it's a binomial. Go ahead and set it equal to 0 first. And then factor out what you can in terms of the GCF. And then this one is not factorable any further, so what you're going to do is you're going to set this equal to 0. And then you're going to solve. So I get plus or minus the square root of 19 over 6. And so what I get here is the square root of 19 over root 6, and then I'm going to rationalize. So I get x to equal plus or minus root 114 over 6.